So I am working as a senior manager in GE Vernova. And today we will talk about the FinOps practices at our company. So can you move to the next slide, please, Kiran?
Yeah, sure.
Okay. So agenda for our today's session is GE Vernova overview. We'll talk about GE Vernova overview. Then we'll talk about the challenges with the cloud financial management. Then we'll talk about the adoption of AWS tools for cost visibility and optimization. Then we will talk about the re-architecting of the platform for cost and efficiency, and finally the question and answer. Can you move to the next slide, please? Okay, so GE is the world leader in renewable energy, power, and digital technology services and solution. So as you know that we are dealing with the carbon emission. So carbon emission footprints are increasing day by day. So our target is by 2030 we should actually go to the net zero perspective. From our company perspective, there should not be any carbon emissions. As far as our work is concerned, so 400 gigawatt of renewable energy equipment installed at our premises. 7,000 plus GTs were largest installed based on GTs, means gas turbines. And 50% of the world gas power generation happened using the GE businesses only. And more than 30% of the world total power, GE provide. And this company is 130 plus year old company. So idea is again to carbon neutrality by 2030. Yeah, next slide, please, Kiran. Okay, so GE Vernova is key to enabling the energy transitioning, as I told you, and our business is in all the areas like wind, solar, thermal, oil, gas, then storage, hybrid solution, nuclear, then mining, then grid, and obviously like digital technology tied to all together, orchestrating the world's energy through software and accelerating decarbonization. So we are making those software which can help in accelerating the decarbonization. Next slide, please, Kiran. Okay, so challenges, you see, like in today's world, what happened is like the biggest challenge in the companies today is like when companies start using the cloud technology, then how to do the cloud financial management, that is the biggest thing for companies to understand. So all these things obviously come under the preview of the FinOps practice. And like here, you see like so many points we are mentioning. Kiran, you want to add here
Yeah.
and talk about those,
Yeah,
please?
sure, Nitish. Yeah. Many of us will agree that cost is one of the first reasons why people move to cloud quickly. However, depending on the problem we are trying to solve and depending on the goals that we want to achieve, we'll need to approach cost from a different angles. So because it is important to distinguish between mechanisms for cost savings, techniques for cost optimization, and the tools for cost visibility and management. So some of the challenges that GE Vernova faced for cloud financial management are listed here. The first one is in order to have better optimization, we need to also ensure better cost management, which is the ability to have the visibility of cost to keep them under control. So we have around hundreds of AWS accounts to manage and monitor the cost, and hence cost management is increasingly important for GE Vernova. And with the divestiture of GE into three companies recently, a lack of consolidated billing at the BU or business unit level and a strategy for a proactive approach to cost management is another challenge. Next is analyzing and visualizing cost and usage across these linked accounts is becoming a pivotal task for us. And understanding long-term on-demand usage for compute and storage, identifying areas of optimization across various work streams. And when it comes to resource utilization, the focus also narrows down to recognizing underutilized or idle resources or instances. The challenge also extends to mitigating high data transfer costs associated with cross-region data transfer. And ultimately, the goal is modernization and efficiency, right? So the scope for improvement lies in practical, actionable steps, and it means that we are using the right amount of resources aligned with the business requirements and pay for what is needed rather than for what is being used. So we look at some of the AWS tools that we've adopted at Vernova for cost visibility and optimization. So we adopt these tools, and these are classified here under 4 phases: see, save, plan, and run. When it comes to the measurement and accountability, or the C phase, we use predominantly the Cost Explorer, Cost and Usage Report, and CloudWatch. So just to give a quick overview on this, using Cost Explorer, we have the visibility into our AWS spend with an easy to use interface to visualize, understand, and manage our cost and usage over time. So we periodically use this to look at month to date, forecasted cost for the month, a graph of our daily cost, our top 5 cross cost trends as well. And we use Cost Explorer to look for patterns in AWS spending over time, projected future cost, identify areas that need further inquiry, also observe the reserved instance utilization and coverage and recommendations. And when it comes to cost and usage report, or CUR, we create these custom reports that analyze cost and usage data. The CUR not only provides us with visibility at a high level, for example, total cost and usage across all the accounts, but also lets us dive deeper into our cost and usage data to identify trends, pinpoint cost drivers, and detect anomalies. Next, coming to CloudWatch, we all know CloudWatch is a service that monitors our application and provides insights into operational health. CloudWatch can also be used to respond to performance changes, optimize resource use. So using CloudWatch, we collect data across our resources that gives visibility into system-wide performance and set alarms to automatically react to changes in the metric being monitored. And the next phase is a save phase, which is for cost optimization. For this, we predominantly use the management levers for reserved instances and savings plan, and also compute optimizer. So for our steady state workloads, GEV reserves capacity upfront by purchasing reserved instances and savings plan that provide a significant discount of up to 70% compared to the on-demand pricing. The reservation is actually shared between multiple accounts that we have within a consolidated billing family. And we also use AWS Compute Optimizer that gives recommendations to optimize our use of AWS resources on EC2, EBS, Fargate, and Lambda. This helps in identifying under-provisioned resources and right-size the workloads. And when it comes to planning and forecasting phase, we use budgets and pricing calculator. Budgets is used to monitor and raise alarms when spending crosses defined thresholds. And we use it even based on tags and accounts as well as resource types. And we use AWS pricing calculator to estimate the cost of various AWS services or groups of services that we use, which helps in forecasting the spend for any new workloads that we are trying to bring in. And finally, when it comes to the operation phase, we use several tools like Trusted Advisor, CloudTrail, Systems Manager, well-architected tool, tagging, and lifecycle rules. Trusted Advisor is used for cost optimization in addition to performance, resiliency, security, and other pillars as well. So with these recommendations, we can identify unused resources, opportunities to lower our cost, and take actions to remediate any deviations from the best practices. And we use CloudTrail mainly for auditing purpose, as it captures API calls for the billing and cost management as events. So using the information collected by CloudTrail, we can determine the request that was made to the API and the IP addresses from which the request was made, who made the request, when it was made, and additional details. And with respect to AWS Systems Manager, it helps improve the visibility and control in the cloud, reducing the amount of time and effort required to manage and monitor our resources, thereby saving cost. And we also use AWS well-architected tool that provides us a trusted framework to evaluate our architecture and implement designs. And we also use other mechanisms like tagging our resources and adopting S3 lifecycle rules, etc., for cost optimization. Next, we'll look at the re-architecting. Over to you, Nitish.
Yes. Can you move to the next slide, please? So let me talk about our architecture here, and let's first understand that what was our architecture look like before doing the architectural changes. So here, like if you see on the slide deck, on the left-hand side, we see one Kubernetes environment. So this Kubernetes environment was our custom Kubernetes environment, which we were using in our platform. Second thing is you see like orange color portworx on Kubernetes side. This is the third party storage we were using with our Kubernetes. Then on top, you see in orange color is the AVI controller, which is third-party load balancers we were using. On extreme right, you see the Cloud Foundry, which is still we are using, is still in a process of migrating that thing to the EKS. And then underneath that one strong SWAN you see, which is the on-prem to cloud connectivity through IPsec tunnel using this open source tool called Strong SAN, and which we were using. Now the problem with this approach was like when we were using the Kubernetes environment or Portworx storage or Strong SWAN IPsec solution or AVI load balancer or Cloud Foundry, that the peak capacity planning was difficult. Continuous upgrade was really tedious task for us, and maintaining the reliability and uptime was another challenge, and we were getting a lot of outages. Then high availability and DR solutions were not that robust, and obviously the licensing cost was troubling us. So these all challenges were there at that time in this technical landscape, and then we thought that let's change these things. And the work which I will going to talk about is not something which we have completed in 6 months or 8 months. It is like from last 3 years, like we are working on this changes in our architecture. Kiran, can you please move to the next slide, please? Okay. So as you see here, like this is from last 3 years. A lot of teams worked together, and finally we got this new architecture. So let me compare this picture with the previous picture. So first thing we talk about our custom EKS. So here that custom EKS, we replaced it with the EKS Fargate, which you see here in the orange color. And this was the very good change for us. I will talk about that soon. Then the second change was the port work. I mentioned that, okay, some third-party storage we were using inside the Kubernetes. So now we replaced that thing with the Amazon Elastic Block Store EBS volume. Third thing I told you, the in orange color in the previous slide was the AVI load balancers. And that actually we changed with the NLB, ALB, Route 53 combination. And other tool you can see here that we are using like ACM and other things, WAF and other things. Fourth component was related with the strong SWAN. Okay, so in a strong SWAN IPsec solution, we changed everything to the transit gateway and AWS site-to-site VPN solution. And like we created two tunnel like for as a high availability solution. So if one tunnel go down, then other can help. And then Cloud Foundry, we are still doing that thing, which is again like we are doing it, changing it to the EKS Fargate. So in summary, our custom Kubernetes, we changed it to EKS Fargate. Then Portworx third-party storage, we changed it to AWS EBS volume. Strong SWAN IPsec solution, we changed it to Transit Gateway and AWS site-to-site VPN. And then AVI load balancer, we changed it to NLB, ALB, and WAF. And obviously, like Cloud Foundry also, we are doing the migration, and that we'll soon changing it to the EKS Fargate. Next slide, please. Okay. So here, like the best practices, what we adopted for doing the cost saving, if I say that we tried to find that like what is tagged, what is not tagged. So based on that, we did a lot of things, and Kiran will talk about that in detail. But that is one thing. Then obviously design consideration. In design consideration, you can see that we did a lot of auto scaling, right sizing, optimization, and use of container, serverless. And then system manager, we started using again, like we'll talk about that in our upcoming slides. And then obviously reporting on saving is the key thing, continuous cost optimization, tracking, and saving over time. And I think Kiran, go ahead.
Yeah.
If you want to add more here, please go ahead.
Yeah, so we implemented a comprehensive tagging strategy for the entire business. We tag based on projects, environments, workload, which helps us in understanding our bills and our billing reports more effectively. And coming to the design considerations, we implemented the list of features that we have highlighted here. So one is auto scaling. So with auto scaling enabled, our workloads optimize the utilization and cost efficiency when consuming the services. So we only pay for the resources that are actually needed. When demand drops, auto scaling will automatically remove any excess capacity to avoid overspending. And we also do a lot of right sizing and downsizing. So here's an example. For example, we may have over provision the resources during our initial migration into the cloud. So that what we do on a periodical basis is to review the current load by checking the CPU, memory, network, disk IO, and then baselining the instance. So we identify a smaller instance type that can match the performance characteristics that our workload demands, and then we change the instance type and do another performance review. So we do this in a periodic basis just to get the resource right sized. And another important thing that we have adopted is going for serverless. That helps optimize cost as well for our workloads that does not have a steady state usage. And we also adopt cheaper storage tiers in S3 by using lifecycle policies, and also system manager for automation, especially to automate the installations of vulnerability detection tools. It provides a unified interface to manage and monitor the resources. Thereby, it makes it simpler for identifying and troubleshooting issues, and also saving cost by reducing the amount of time and effort required to manage and monitor the resources. And finally, we want to highlight that continuous cost optimization is a key for realizing maximum savings, and it actually requires a paradigm shift in the mental model. So with frequent cost up initiatives, we eventually get to this point where we actually pay only for what we need, and it need not be always proportional to the usage.
Okay.
Yeah, over to you, Nitish.
Yeah, so this is the overall realized saving across multiple accounts. And here, we achieved over like 14.6% saving per year. And by doing the decommissioning of third-party resources and licenses and moving properly into the AWS native services. Second thing is like here is the service specific cost optimization was the biggest 31% saving this component gave us. And the third component was the decommissioning of inactive account and untagged resources where we got the 14% of the saving. Now, if we go to the right side here, you can see the bifurcation, further bifurcation. Like if you see the Elastic Cache, EFS, KMS, then Cloud HSM, then DynamoDB, RDS, EC2, then S3 versioning. These all component only like optimization gave like 29%. Like then EBS volume, GP2 to GP3 upgrade and IOPS optimization actually gave us the 26% of the um, return here. Similarly, I will not go in more detail, but you can see here like so many things we got from Trusted Advisor, Config, Private CA, CloudWatch, CloudTrail, CloudFund, then Kinesis Firehose, VPC flow log, deletion of unattached EPC, EBS volume, then auto scaling groups and associated ELBs. So many things, we have changed to achieve this 14.6% per year. And all our teams work together as a one team with the business, with the product owners, and everyone to get this figure, and which was very encouraging. Yeah, Kiran.
Yeah. So we are at the end of the presentation, so we open for any questions.
Yeah, yeah. So thank you for joining this session, and yeah, please ask your questions.
Thanks, Kiran. Thanks, Nitish. That was like a great achievement you guys have managed to achieve in the last couple of years and couple of months there. So I see there is one question in the chat. Is G Vernova part of the OSDU, the open source subsurface data universe standards?
Yes, yes.
Okay. And so just for the benefits of everyone, if you could explain what does this mean and How does this help?
This open source one.
Yeah,
Okay, so if
open
I
source.
understood, yeah, if I understood your question correctly, so what we do is like whatever codes we are creating, few things we are like anyone across the board can first of all contribute in that within our company. That is one thing, and whatever the open source community standards are there for writing that code, we follow the same in all our scripting and all our tools. Does that answer your query, Ankush?
Yes, I hope Srinivasan, who this helps to answer your query. Okay. So next question is, does the architecture support high availability, and what is the DR strategy employed?
Yes, so high availability, yes, definitely it support the high availability. And because if you see here in our EKS Fargate cluster, anyway, it is in a multi availability zone. So that is one thing. DR strategy, as of now, we are still working on that. We are taking, like, we are planning to take a lot of backup, recover, restore, and we are working all this cluster in multi region also, for example. So yes, two, three things still we are working on that, and this project is still in like work in progress stage. So our teams are working on that.
Right. And how do you address the challenges of continuous upgrades to the new architecture or to the latest coming to the latest ones? Yeah.
Correct. So upgrade means only specific to Kubernetes you are asking, or in
It
general you
should
are
be
asking?
in general to all any of the applications or the softwares that you would have deployed or the service that you are leveraging.
Correct. See, as a company strategy, we are moving with all AWS native service, first of all.
Okay.
So, like when we plan to change all these third-party tools, um, it was based on the direction that this is our next 2-year plan or 3-year plan or whatever. Okay. And based on that, our company decided that any tool, whatever we are using from third-party tool, third party, we should find a comparable tool in AWS, and we need to work together with AWS team to implement that thing. So that way we are doing the upgrade from legacy to modern services, first of all. And other aspect can be here is like software upgrade. Like now we are on EKS Fargate, for example, and then if we need to do some upgrade, then obviously AWS is there to help us, and we are doing those things um, by coordinating with AWS.
Okay. And the last one is, how do you find out the underutilized resources to decommission or the downsize them? Can you give some examples of
Yeah.
real-time real world use cases that you would have come across?
Yes, yes, yes. So here, like the obviously first thing is like as Kiran talk about, we first we are first relying on all the AWS related tools. So like for example, let's take one example. The trusted advisor say something to us that okay, trusted advisor say that okay, these all instances we can optimize.
Hmm.
Okay, and or these all instances we can decommission. But now the challenge is that we need to see that how much is the users pattern in those instances in real time, and so many accounts are there, so many instances are there. So in our environment, what we are doing is we are using the Python scripts, and then as I said earlier, that we are using the system manager also. So we create the documentation in system manager. We write this file with and our manager, and then it fetch all the details about the utilization of those instances. And then when we see the utilization of those instances, um, then obviously we decide that okay, these instances can be the good target for decommissioning. And then obviously as a process we check with the service owner to confirm further, and then we do the decommissioning. This is just one example for EC2 instance. Same goes for RDS, which is very different from EC2, if I say. And then in that also we have different script to capture these details.
That's great.
And
Thanks so much, Nitish. Thanks so much, Kiran. That was a wonderful presentation.